All right, so the last part of 3.5 is our reflection and then combining multiple transformations. So the reflection piece, we're going to be reflecting over the x-axis and over the y-axis. So when we're reflecting about the x-axis, that means that we have a negative on the quote unquote outside of our function, okay? And because it's here, that means that it's directly impacting our y's. So we're taking all of our y's and multiplying them times -1. When I'm multiplying the y's times -1, essentially I'm just changing signs, right? Okay, so we're changing the signs. All right, after that, next would be your reflection across the y-axis. When you're reflecting across the y-axis, that means that we are changing our x values. We're going left and right across, right? And so because we're reflecting across the y-axis, that means we're changing the signs of our x values, right? So our x values are now changing signs, all right? So we're going to look at this combined with other transformations to see how it all comes together. Okay, so let's look at an example. So here we have the function of y equals x squared, right? Which is just the parent function. And we want to create a function and graph and transform this into something, right? So we're going to apply the sequence of transformations to the function. So we have y equals x squared, okay? When we're looking at this, we need to keep in mind each piece of a function transformation, okay? So when we have our function, your a is on the outside, right? Your f of x on the inside, that's your overall transformation, your b, your all that. So you have your b, and your b is going to be x minus your c or h, depending on the lesson, plus your k. So these are all the ways that it's going to, and the reason why we write it in this notation is because these rules apply to all functions. So depending on what your function is how it's going to change, okay? Just remember that each piece has a role, okay? When your a or b is positive or negative, that's your transformation, okay? So first up, it says here, we're going to shift right 3 units. So if I need to shift right 3 units, that's going to be my C, my horizontal or my H transformation, right? So when I'm looking at this, so it's our C / our H. And remember, we kind of talked about if I'm going right and left, my X is going to be a liar. So when I write it in, yes, I know that this means it's equal to 3, but I need to make sure I understand that this is going to look like a -3 for my C. I'm going to just write it as normal because I feel like it'll be easier to explain. So our C equals 3. Now we're going to reflect about the x-axis. Because I'm reflecting about the x-axis, that means I'm going from top to bottom. In order to go from top to bottom, that means my y values have to change, okay? If my y values are changing, that's going to be affecting, that's the A, right? So I know that A has to be a -1 right? And then I'm going to shift down 2 units. So that's going to be my DK situation. I need to make sure that if I'm not going to use H, I don't use that. So A, B, C, D, which is what's on our chart, okay? And so this is going to be a D situation. So my D is going to have to equal -2 because I'm shifting down. So when I put it all together, what do I get? So putting this together, we are graphing y equals x squared. So because we are doing y equals x squared, the transformation would look something like this. Y would equal your A parentheses, your B times your x minus your C squared plus your D. Okay, and that's what we're plugging in. So now we have all the parts that we need. And because there is no B value or transformation, our B is automatically just going to be 1. So when you're multiplying, the value that doesn't change anything is 1, right? So our B is just going to be 1, all right? So we have y equals, our A is now -1, parenthesis, Our B is just 1, so we can write it just so that we can see it because nothing happened to B. There was no change. Minus our C. Our C is 3. Okay, remember I said it's going to look like it's not a positive, but it is. And this is going to be squared and then minus our D. Okay, we're going to clean this transformation up a little bit. I'm going to pull a little geometry thing here and put a little T so you know this is my Y transformed. So cleaning this up, I have negative x minus 3 squared minus 2, and that would be my transformation. So I'm going to go graph it so that you can see what that looks like. So initially, I'm going to reset second plus 7, 1, 2. Initially, we were at y equals, so we had y equals x squared. So it looks like this. Bam. Then it told us that it wanted us to shift right 3 units, reflect about the x-axis, and we want to shift down 2 units. So we created our transformation. We identified our C, our A, and our D. And because our B wasn't here, our B remained 1. We simplified, and this is now our new function model. So we're going to graph to see if all 3 of these transformations take place based on what we created. So we have negative x minus 3 squared minus 2. Okay, so it's going to graph the original, and then it's going to graph our new one. And our new one, did we do what it said? Did we go right 3 units? Yes. Did we reflect over the x-axis? Yes. And did we go down 2 units? Yes. So this is why that would be our transformation. Okay, so there's that. All right. The last example for our notes is putting multiple things together. So here we have f of x equals x squared over 2 plus 1, and it wants us to find the domain and range of f. So we're going to let h of x equal our original function. Let me minimize my calculator. So we're going to let h of x be our minimum function, our original function, our parent function. So for this, we're going to let this be our PF, our parent function. Our parent function, if I have x squared over 2 plus 1, that means our parent function is x squared, right? So our parent function is x squared, which is no transformation done to the quadratic function, right? For our parent function, its initial values are going to always be the same. You can choose 3 or 2 values, however you want to do it. I'm just going to choose, I'm going to do 5. So I have -2, -1, 0, 1, and 2. That's going to help me create that U shape that I'm looking for. And so -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So my parent function is simply for graphing purposes. As you can tell, I did not want to get into a fight with that box at the bottom. So here, I promise you, I do way better drawing on paper. Okay, so there's my parent information, my parent function. Now for f of x. So now we're changing this. Notice that there's nothing happening to our x's, right? X is just chilling by itself. It has its power. There is no B or C transformation taking place. We only have outside transformation. So because we only have outside transformation, that means the only thing that's being changed are our y values, okay? Because there's nothing happening to our x. Only thing that's being changed are our y values. So to our y values, we're doing 2 things here. And you're going to follow the order of operations when you're doing those 2 things. We are dividing by 2 and we are adding 1. Do we see that? So to our y values, we are dividing by 2 and adding 1. Dividing by 2 because these are outside taking place. So our new f of x, our y values, we're taking our parent function values and we are dividing them by 2 and we're adding 1. So to each one of my parent function y values, I'm dividing them by 2 and adding 1. Okay, so that's going to be the transformation that takes place. So we have 4 divided by 2 plus 1, which is going to give us 3. We have 1 divided by 2 plus 1, which is going to give us 1.5. We have 0 divided by 2 plus 1, which just gives us 1. And then these values are going to repeat. So we have 1.5 and 3. So our new place of transformation is -2 and 3. -1 and 1.5. 0 and 1. 1 and 1.5. 2 and 3. So what took place here had nothing to do with the horizontal motion, right? Based on what we have here, we know that our A equaled 1/2. So we had a vertical compression or shrink, whatever you want to call it. Vertical compression by a factor of 1/2. And then our D equaled 1, which meant that we had a vertical translation up 1. So we're compressing and we're translating up 1 unit. So we're going to see if we did it, then that's what our graph should look like. So we have -2, 3. So I'm going to go to -2. And I'm going to go to 3. 1, 2, 3. Okay. We're at -1, 1.5. So we're going to go to -1. And we're going to go to 1.5. So it's right there. A little bit above. 0, 0. So 0 is still at 0, 1. I'm sorry. I highlighted and everything. And then we're at 1. We're at 1.5. And then we're at 2, 3. So I'm going to go to 2, go to 3. So you can see that even though it's not like a big one, but we were compressed. Trying my very best to draw, y'all. I don't know why I can't draw. I have some theories. I blame the pen. No. I erased it all. Hold on. Let's see if I can reconnect the reds. Okay. I'm doing my very best to do the purple. I think it would help if I like went ahead and did the 9. 9 divided by 2 is 4.5, which is going to put us at 5.5. 1, 2, 3, 4, 5. So I'm trying to go like this. I didn't go out perfect on that one. You're probably like, lady, just draw this. I know. I am. All right. So you can see it got a little wider. It was compressed by half. So we can see it expanded. And that's it. So make sure you're paying attention to the rules. Make sure you are taking your time. You can use your calculator as a resource to complete your graphing. But remember, when it's just asking you to simply describe, you're paying attention to how the function is being altered, okay? And so this would be a great point of reference to come back to as you're doing that. All right, that concludes 3.5, which ends our last section for chapter 3. Thank you.